Hi, sixth grade. This video is going to all be about the tools that we're going to be using with measuring a liquid. Now, we already focused on measuring the volume of a regular solid, but that's not going to help us a whole lot with our recipes. You should have been telling yourself, okay, I'm not really going to be putting perfect blocks of ingredients into my recipe. So finding the volume of a solid isn't going to help us with our big problem. We do know that we have a lot of liquid ingredients and we have some powdered ingredients that don't come in perfect blocks. So our next tool that we're going to talk about is probably going to help us a lot with some of those irregular solids in liquids. In the kitchen, when we're looking for tools to measure, a lot of times we are using, for small amounts of ingredients, tools like this. So this would be, this big one is 1 tablespoon. We have 1 teaspoon and 1/8 of a teaspoon. So when you're measuring like your salt or your vanilla extract or any type of seasoning, we're probably going to be using those smaller measuring spoons. When we need like sugar, we might need more of that, so you might use 1/2 of a cup, something larger so you can kind of see the comparison there. And then really small, so that was our 1/8 of a teaspoon. Now, tablespoon, teaspoon, cup, those are all going to be in the U.S. customary. And we said that our goal is to first make a recipe that the entire world can use. And second, we're going to write a recipe from the kind of the outlook of a food chemist like Alton Brown. So we're going to be putting a science twist onto our pancake recipe. And so when we look here, it's going to be important. We're scientists, and majority of the world's using the metric system of units. So we need to be using metric system as well. So if you're using 1 teaspoon, that's going to be equivalent to about 5 milliliters. 1 tablespoon is going to be about 16 milliliters. And then that 1/2 cup that I showed you is going to be 20 milliliters. So this I will actually print off and have it hanging up in our classroom for you guys. But knowing these conversions is going to be really important when we actually get to that problem area. Now, we are, like I said, going to be taking a science twist on things for our recipe. So measuring volume with these isn't going to give us as accurate of a measurement as measuring with a graduated cylinder. So this whole video is going to be about just using the graduated cylinder. You should have your notes page out. This was something that you started when you took notes on how to find the volume of a regular solid. So you should know the definition of volume. What exactly are we measuring when we say we're measuring the volume of an object? And then you have your notes for regular solid. We aren't going to talk about liquid and irregular solids just yet, so you can flip your page over or scroll down depending on if you are using a digital copy or a paper copy. So go ahead and pause your video and get your notes page out. So like I said, this whole video is going to be all about using a graduated cylinder. Now, graduated cylinders actually come in many different sizes. So we're going to jump down here to this number 1 and fill in that blank. You can have very large graduated cylinders. And so this will actually fit 1,000 milliliters of liquid. This one's also fitting 1,000 milliliters. It's shorter, but you can see it's wider. So that's how we're still able to fit the same amount of liquid in here. Then compared to this one, we can go really, really tiny. This would only hold 10 milliliters. And then I have some other ones kind of filling in here. This is holding 50, and then this one is holding 100. So you can see many different sizes. And the other thing is you can see this one, and I know it's hard for you guys to see the number. We're going from 900 to 1,000, and then there's 9 little lines in between. On this one, we're going from 90 to 100, and there's 9 little lines in between. On this one, though, we're going from 10 to 9, and there's only 4 lines in between. So not only are the sizes of the graduated cylinders different, but our increments in which our scale is going to be going up by are different. It's kind of like when you guys work with graphs. You have your scale that you have to figure out, and then you have to figure out how much your scale is going to go up by. So those are called increments. Same thing with our graduated cylinder. So the first goal is going to be able to figure out the scale increment, or how much each line is going up by. And these lines actually have a specific name. So when you have the large lines with large numbers, those are called graduations. So that's up in our key terms here. So we have large lines with large numbers. And then if you look here, the small lines in between with no numbers, we call those sub-graduations. So smaller lines with no numbers. So in order to figure out what these little sub-graduations are going up by, some people can just guess at it. They're very good at just looking and figuring out what they're counting up by. Some people are not very good at that. There is actually a formula that we can use in order to figure that out. So, or there's a series of steps, I should say, not really a formula. The first thing that you want to do is choose 2 graduations, and it can be anywhere on the graduated cylinder. It can be up at the top, it can be down in the middle. So I'm actually going to look right here in this one, and I know it's so hard to see. This is actually the 40, and then my next one that's right next to it is 30. And so I tried to give you a picture right up here. Let me make it a little bit larger. You can see here there's 40 and there's 30. These are 2 marked lines, and the other rule is that the numbers have to be right next to one another. So I could choose 40 and 30, or I could choose 40 and 50. We're going to use 40 and 30 for this example. So we're going to subtract these 2 numbers. So subtract the values of the 2 marked lines. So we have 40 minus 30 equals 10. Now the next step that you need to do is you need to divide by the number of spaces between the 2 graduations that you subtracted. So the 2 graduations that I subtracted, and I think I'm going to go up and look at this picture now because it's easier for you guys to see. The 2 graduations that I subtracted are right here, and I'm going to count the number of spaces in between. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 spaces. So I took this number here, notice it's in blue. So I took the number that was the difference from above, and then I divided by, this was my number of spaces. So that's going to be 10. So 10 divided by 10 is 1. This number, which is called, do you guys know what the answer to a division problem is? The quotient. Let's see if I spelled that right. Nope. There we go, missed it in my eye. So the quotient is the number you will count up by. So since the quotient was 1, I'm going to count up, and each one of these should go up by 1. How I'm going to double check my answer is I'm actually going to count up by 1s and see if I come up with 40. So if I start by 30 and count up by 1, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, I ended at the right number. I know that I did all of my math right. So just a few other things when you're using a graduated cylinder, some helpful kind of hints and tricks. You always want to make sure that your graduated cylinder is sitting on a flat surface. If you're holding it like this, you could be kind of moving it, and I have some liquid here so if I'm holding it like this, it could be tilted just a little bit. So always make sure that it's on a flat surface, and then you have to go down and get it eye level with it. You guys have gotten some practice at getting that eye level with your triple beam balances to really make sure if it's balanced, because we know looking at things from different angles kind of messes with your sight. So that's why you really want to make sure that you're at eye level with it. So there's a big eye there, making sure you're at eye level. And what you're getting at eye level with is called the meniscus. So up here in our key terms, we have one line here. It's called a meniscus. The meniscus is going to be the curve that you see at the top of the liquid. So if I hold this up here, I don't know, it's probably difficult for you to see. It looks like there's a contact lens floating on my graduated cylinder. So I have a picture of what that looks like. See how it looks like there's that contact lens? What's happening is the molecules of the water actually get attracted to the sides of the graduated cylinder, and so it pulls the water a little bit and makes it kind of curve up. So that curve we call is the meniscus. And we always want to read our measurements from the bottom of the meniscus. So we're reading from this bottom part here. So if we were looking at the graduated cylinder, we know that this is coming up by 31, 32. So you're going to go to the bottom point there, which is actually at 32. And so that's how we would read from the bottom of the meniscus. So you now know how to use a graduated cylinder. And we're actually going to be using the graduated cylinder for not just liquids, but you're going to see how we can use the graduated cylinder for finding the volume of an irregular solid as well. So these steps you're going to be doing, you're going to really need to make sure that we're getting really, really good at this. The next video is going to be super short because it's just adding the liquid and seeing how to find the volume of a liquid. So if you have any questions, because I know finding the graduates can be very, very difficult, please make sure that you let me know.